Hey everybody, welcome to the last section of chapter 13. This one's going to take a long time because each one of these are very lengthy. For the first one, for example, we have to find the t, n, and k of the plane curve r of t equals 4ti plus 4 ln cosine j from the bounded negative pi over 2 to pi over 2. So let's begin. We have our function r of t equals 4ti plus 4 ln cosine of tj in that bound. We have to find t, n, and k. So let's figure out, look at those formulas. T is v over magnitude of v. K is 1 over magnitude of v times the magnitude of t dt. And n is dt with respect to t over the magnitude of dt dt. All right, so let's begin. We have to first find v in order to find t. V of t is the derivative of RT. Derivative of 4t is 4. Derivative of 4 ln cosine t, 4 is a constant, stays there. The derivative of ln is 1 over x, which is 1 over cosine, times the derivative of cosine is negative sine. So that equals 4i minus 4 sine t over cosine t j. Sine over cosine is tangent. So that's what our v equals. The magnitude of v is 4 squared plus negative 4 tangent t squared. Right, so that equals 16. 4 squared is 16. Tangent squared. Right, so they both have 16. We could factor out a 16. Leaving us with 1 plus tangent squared t. Which we could now do both of these separately. Square root of 16 is 4. 1 plus tangent squared is an identity. If you look at your trig sheets, we see 1 plus tangent squared equals secant squared. So we could put secant squared t, which means it's square root of 4 secant. Square root of secant squared is secant t. So that's what our magnitude is. All right, so from here, we can now find t. B is equal to 4i minus 4 tangent t j all over 4 secant t. Separate all these. And simplify. Force cancel. So we have 1i or I over secant t. Or let's put 1 over I that way. Minus the force cancels. So we have tangent over secant j. All right, now go ahead and we can rewrite these. Secant is 1 over cosine t. Tangent is sine over cosine. So we have 1 over cosine, which is reciprocal, which is just cosine t. So we had 1 over cosine. Take the top, leave it alone, flip the bottom. 1 over cosine on the bottom becomes cosine I. We have sine over cosine, 1 over cosine. So leave the top alone and flip the bottom. Cosines cancel. T is equal to sine ti minus cosine ti minus sine tj. So that's my t. So this is cosine t minus sine t. Right, now we got to figure out what n is. Remember from our formulas, n is the derivative of t with respect to t over the magnitude of the derivative of t over dt. So that means we have to find the derivative, and then we have to find the magnitude of the derivative of t. So the derivative of cosine is negative sine. Derivative of sine is cosine. Okay, we have the numerator. Now we've got to find the magnitude of that. Negative sine t squared. Negative cosine t squared becomes sine squared t plus cosine squared t, which is 1. So n dt is negative sine ti minus cosine tj over the derivative, which is 1, So n is just the numerator. Just cosine tj. That's what n is. So negative sine t, negative cosine t. Okay, the third part of this question, which is one part C pretty much, is find k. And again, k, the formula is 1 over magnitude of v times the magnitude of the derivative of t. The magnitude of v from our first page was 4 secant t times on the second page, the magnitude of the derivative of t is 1. So k is equal to 1 over 4 secant t. Again, secant t is 1 over cosine, so it's cosine t divided by 4. There's our final answer. All right. Let's get sheet number 2. Question number 2. All right. Find t, n, and k again for the space curve t is greater than 0 of r of t equals 9 cosine t plus 9t sine ti plus 9 sine t minus 9t cosine t j plus 2k. T is greater than 0. Find t, n, and k. Again, t, the formula for that was v over magnitude of v. N was the derivative of t divided by the magnitude of the derivative of t. And k, 1 over the magnitude of v times the magnitude of the derivative of t. So we'd first find v. So the derivative of 9 cosine is negative 9 sine t. Plus, this is now the product rule. So take the derivative of the first one, which is 9. Leave the second one alone. Plus the derivative of the second. Sine is cosine. That's I. Same with the second one. So we have derivative of sine is cosine minus the derivative, yeah, minus the derivative of 9t is 9. I put a parenthesis there because now this negative sign is going to change everything. And this is a product, so I have to, there'll be a plus sign there. Derivative of 9t is 9 times cosine t plus 9t derivative of cosine is negative sine t j. And 2 is a constant, so it disappears. So we have negative 9 sine t plus 9 sine t plus 9t cosine t I plus 9 cosine t, distribute that, minus 9 cosine t minus 9, well, that's a plus because that's a negative, so it becomes a plus 9t sine tj. Negative 9 plus 9 cancel out, so it's 9t cosine ti. The 9t's cancel, so it's plus 9t sine tj. Now I gotta find the magnitude. Nine t cosine t squared, 9t sine t squared. (81 t squared cosine squared t). 81 t squared sine squared t. They both have 81 t squared. We can factor those out. So we have cosine squared t plus sine squared t. That equals 1. So the square root of 81 t squared, square root of 81 is 9, and t. Yeah. So to find t, it's v over the magnitude of v, which is 9t cosine ti plus 9t sine tj over 9t. The 9t's up on top cancel, or I can factor them out. So I have cosine ti plus sine tj over 9t. So the 9t's cancel. So t is equal to cosine ti plus sine tj. And that was my first answer. Cosine ti plus sine tj. Now I gotta find n. Now I gotta find n, which the formula is the derivative of t with respect to t, and the magnitude of the derivative of t with respect to t. And we know that t equals cosine ti plus sine tj. So the derivative of t with respect to t, cosine is negative sine, sine is cosine, and the magnitude negative sine t squared plus cosine t squared sine squared t plus cosine squared t, which again is identity. Square root of 1 is 1. So n is dt, which is negative sine ti plus cosine tj over 1 plus cosine tj. So that's what n is. Negative sine t plus cosine. Now we have to find k. One over the magnitude of v, dt. V, the magnitude of v was 9t. Derivative, the magnitude of the derivative was 1. So k is equal to 1 over 9t. All right. Let's do the same thing with number 3. Define ntk with number 3. So r is equal to, where's that? Parenthesis 4 cosine cubed t I 4 sine cubed t j. And it's within that bound. So we have to find t, n, and k. So to find t, we need to find v and magnitude of v. So the derivative of the first one, derivative of the outside, so it's 3 times 4 is 12 cosine 2t times derivative of cosine, which is negative sine. So that one equals negative 12 cosine squared t sine t I. Same thing in the second one. 3 times 4 is 12. Take derivative sine, so it's sine t. Now derivative of sine is cosine t j. So that second one's 12 sine squared t cosine t, J. All right, now the magnitude. Right, so it's -12 cosine squared t sine t squared, 12 sine squared t cosine t squared. So this, and this is a short one compared to ones coming up, the ones I was looking at. So for this one, do it to distribute the whole thing. So -12 squared is 144. Cosine squared is cosine to the 4th. And then sine squared t. Same thing here. Sine to the 4th t cosine squared t. So they both have a 144. Actually, let's see what they have in common. They both have a 144. They both have 2 cosines and 2 sines. So I took out the 144, took 2 cosines out, so I have 2 left. Those are all gone. That's gone. That's gone. So I have 2 more of those. This is an identity. These are all the products. So the square root of 144 is 12. Square root of cosine squared is cosine. Square root of sine squared is sine. So that's my magnitude. So T, V over the magnitude of V. -12 cosine squared T sine T I sine squared T cosine T J. Here's my V. All over. Well, it's going to be over each one separately. So 12 cosine T sine T, 12 cosine T sine T. 12s cancel, sines cancel, 1 cosine. 12s cancel, cosines, and 1 sine. So T equals negative cosine T plus sine T. Negative cosine T sine T. Now I gotta figure out what N is. Remember the formula for N. Over the magnitude. And our t was negative cosine t plus sine t. So the derivative of t with respect to t, derivative of, this is I and j. Derivative of negative cosine is negative sine. So it's negative of negative makes it a positive. Derivative of sine is cosine. J. So it's over dt dt. And so we see that that's going to be identity sine squared t plus cosine squared t. That equals 1, so the derivative is 1. So n is simply the numerator, which is sine ti plus cosine tj. And we're going to find k. One over the magnitude of v times the magnitude of t. The magnitude of v, where's v? That was 12 cosine sine. So 1 over 12 cosine t sine t times the magnitude of 1, magnitude as 1, which is 1 over 12, 1 over cosine times 1 over cosine times 1 over sine equals 1 over cosine is secant, 1 over sine is cosecant. So it's going to be either one of these, whatever the system will take. Either going to be that or that for k. I'm going to write that because I don't have much space. So it's secant t cosecant t of 12 over 12. All right. Now, question number 4. The curvature of a helix r equals a cosine t plus a sine t plus btk with a and b greater than positive is k a over a squared plus b squared. What is the largest value k can have for a given value of b? All right. R of t equals a cosine t I plus a sine t j plus btk, where a and b are both positive, and k is equal to a squared plus b squared. Right. Well, let's work this out slowly then. Well, actually, since we know what K is, well, let's go ahead and make sure K is actually that. Derivative of cosine is negative sine. Derivative of sine is cosine. The magnitude we know it's going to be a squared sine squared a squared cosine squared. Cosine squared is 1. So square root of a squared is a. So t is negative a sine t over ai plus a cosine t over a. Those cancel. So t is simply negative sine t plus cosine t. And the derivative of t, no, that's the magnitude of t on the bottom. So it's the derivative of t over t divided by the magnitude of derivative. So let's find the derivative of t. Derivative of sine. Negative sine is negative cosine. Derivative of cosine is negative sine. And so the magnitude is going to be cosine squared sine squared. Again, it's going to be 1. So the denominator is 1. So all we have on top, our answer is n is that. N is cosine ti minus sine tj. To figure out k, we need 1 over the magnitude of v times the magnitude of dt. The magnitude is 1 over a. Dt is 1. So we got for ours is 1 over a for our k. That's because I forgot all about b. I forgot all about b. So that means the magnitude of that is bt squared plus okay, so no, that's a derivative of bt is just b. No. So it's just b squared. So it's the magnitude of a squared plus b squared. Let me redo that one. I totally forgot about the B value. This is number 4. A cosine T I, A sine T J, BTK. Negative A sine T I, A cosine T J plus BK. The magnitude of V. Negative A sine T squared, A cosine T squared plus B squared. A squared sine squared, A squared cosine squared plus B squared. So out of these two, I could group them. So if A squared sine squared plus cosine squared plus B squared, that's an identity. So we have square root of A squared plus B squared. That's my magnitude of V. So T is negative A sine T I plus A cosine T J plus BK all over A squared plus B squared. So now I got to find the derivative and the magnitude of the derivative. This one, this is bad. So we have to take a derivative of T. This doesn't have T, so it just stays out in front. The derivative is simply the top. So the derivative negative A sine is negative A cosine T plus, actually it's going to be a minus because a negative sine T, and derivative of B disappears. So it's negative A cosine T I minus A sine T J over the radical A squared plus B squared. Now we've got to find the magnitude. Cable out of there. There. We have negative A cosine T over radical A squared plus B squared squared, negative A sine T over radical A squared plus B squared squared. So it's negative, that's gonna be a positive a squared cosine squared t over just a squared plus b squared. Same thing with the other one. A squared sine squared t over a squared plus b squared. Again, cosine squared plus sine squared is 1, so we have no, we factored out the a squared, so we just have a squared over a squared plus b squared, which becomes a over the radical a squared plus b squared. So that's dt. So we have to divide both of those. Radical a squared plus b squared under negative a cosine ti plus a, minus a sine tj, a the square root of a squared plus b squared flip those two, so we have on top negative a cosine ti minus a sine tj. Flip the bottom one. Radical a squared was b squared over a. So those cancel. The a's cancel. So we have negative cosine ti minus sine tj. That's what n equals. All right. So for k, to find k, we have 1 over the magnitude of v times the magnitude of dt. The magnitude of v is radical a squared plus b squared. And the derivative, magnitude of the derivative is a over radical a squared plus b squared. Radical times radical canceled out, so it becomes squared. Okay, now since we proved that, since we're looking at this one, it says what's the largest value k can have the given value b? What we have to do now, this is a maximum problem. So max min back, because it's asking for what's the largest. B. So that means we have to take a derivative of k. So to take derivative of k, we have the numerator and the denominator. The derivative of a is 1. The derivative of 2a of a squared is 2a. So we have a squared plus b squared times 1 minus 2a squared all over the denominator squared. Simplify the numerator. 1a squared minus 2a squared is negative a squared. And to find the maximum, we set it equal to 0. The only time a fraction can equal 0 is if the top is equal to 0. So we know that b squared is a squared, square root both sides. B equals a. So if b equals a, then our original equation, our k equation, is b over b squared plus b squared. B's cancel, so we have 1 over 2b. That's the largest it can be. So the answer is 1 over 2b. All right, so that's that one. Let's look at the next one. There's 5. Okay, granted, I didn't have to go through all that stuff first time because it gave us what k equals. It's a max and min problem. I thought I just want to make sure that it's a true value. It never hurts to practice. The graph y equals f of x in the xy plane automatically has a parameterization of x equals x, y equals f of x. And the vector formula r of x equals xi plus f of xj uses this formula to show that if f is twice differentiable function of x, then k of x is equal to the magnitude or the absolute value of f prime of x divided by the denominator 1 plus f prime of x squared to the power 3/2. Then use the formula for k for the curvature of y equals ln secant x and show the curvature is 0 at a point of inflection. Now, our point of inflection is a second derivative set equals 0. Okay, this is, like I said, they're going to get long in this problem. Oop. 5. So what do we know? We know y equals f of x equals x, and we know that r equals xi plus f of xj. Yeah, but it's just the parameterization is the first one is the domain, the x value in the range, and the second one. So use this formula to show that if f is twice differentiable function of x, okay, then we got to go from there. Okay. So it's twice differentiable. That equals derivative of x is 1, so it's just I, plus f prime of x j. This equals v. So v prime is r double prime. Derivative of I01 is 0. So we have f double prime of x of j. We have to find the magnitude of v first. One squared plus f prime of x squared. So I plus f prime of x j over the square root of 1 plus f prime of x squared. But we have to find k because that's what it's asking us to find. Twice differential function of x. Then we have to find k, right? So we found t. To find n, the derivative of t over t, and the magnitude of the derivative of t over t. So for here, we have to find the derivative of t. This is where it's going to take the most time. We have a quotient rule. And the denominator, make it 1 plus f prime of x squared to the power 1/2. The derivative of the first one. Derivative of 1 is 0. It's j. Now the derivative of the denominator. The 1/2 goes in front. One plus f prime of x squared, subtract 1. Now times the derivative of the inside. Derivative of this one is 0, so the derivative of that one is 2 f prime of x times f. So it's the outside and the inside, so it's f double prime of x. So we have 1 plus f prime of x squared to the power 1/2 times the f double prime of, let's leave it as x j minus I plus f prime of x squared time the 2's cancel. So it's 1 plus f prime of x squared times f prime of x, f double prime of x. all over the denominator. 1 plus f prime of x squared. Okay, simplify this if possible. Let's see, because we have a denominator here. Radicals here. 1, but that's a negative, so it goes on the bottom. F prime of x squared. And the rest goes on top. I plus f prime of x squared j times f prime of x f double prime of x. And on this side I have the square root of 1 plus f prime of x squared times f double prime of x j. All over 1 plus f prime of x squared, because those cancel. So I have to get a common denominator here. So I'm going to multiply top and bottom. Radical and radical makes it a non-radical. We have a common denominator here. So on this side, radical makes it 1 plus f prime of x squared times f double prime of x j. And on this side, I have plus f prime of x squared f prime of x f double prime of x. Okay, we have this and this. We can factor out the top. Well, let's combine these. If we flip this over, then we have 1 plus f prime of x squared. This is 1, that's half. So it's 3 over 2. Let's combine these two. So I have to worry about the top. They both have a 1 plus f prime of x squared. J minus f prime of x f double prime of x I. It's I, I'm sorry, yeah. So I can't combine them. So I have a 1 plus f prime of x squared times the double xj minus I. There's no I there yet. This is just the top. So I have f double prime of xj plus f squared f double prime of xj minus f of x f double prime of x I minus f prime of x squared f prime of x f double prime of x. F prime of x squared that's not squared. Anything with the I is not squared. X squared f double prime x j minus f prime of x f double prime of x I minus f prime of x f prime of x f double prime of x j. So we see f prime of x squared f double prime of x j f prime of x f prime of x, what's f prime of x squared f double prime of x j. So these two cancel. Minus f prime of x f double prime of x I all over 1 plus f prime of x squared to the 3/2 power. And all that was just for t prime. That's our dt dt. Now the magnitude of dt dt well, this is the I should go first. X minus, so it will be plus, which makes this one f prime of x squared. That's the IHJ all over 1 plus f prime of x squared to the 3/2 power. That's squared. F prime f double prime squared f double prime squared. Those cancel, so we have 1 plus f prime to power 3. All right, so k is 1 to that magnitude of dt. Where was that? Magnitude of v is 1 over radical 1 plus f prime of x squared. Times the radical of f prime f double prime squared plus f double prime squared over radical 1 plus f prime squared cubed. That means 2 of those are out. Those 2 radicals cancel. So we have 1 plus radical. So on the bottom we have 1 plus f prime squared squared. F prime f double prime squared plus f double prime squared. All right, where's that question? Let's place that sheet. Okay, yeah. In vector form, use this formula to show that if f is specified. Yeah, we found. Okay, let's look at this. That should prove it right here. the first part. So K is equal to F prime of X, F double prime of X squared that cancels. So on the bottom we have okay on the top. We can combine these. So we have F prime of X squared, F double prime of X squared. So I can factor out F double prime X squared, leaving me with Fx squared plus 1. Okay, yeah, we square root of that. That's that one. We can rewrite that, so it's 1 plus F prime X squared. This one should cancel this one. Oh, okay. We start off with here, squared. Oh yeah, it should be squared, not. So yeah, it's just carried on from here. We had, this was cubed here, which when we square rooted it, that means 1 came out and 1 stayed in radical multiplied by over V. So those cancel out, radicals cancel out. So you have 1 plus F prime times F makes it squared. So that should come over here. So that means over here, we have one plus f prime squared. So square root of f prime squared is the absolute value of it. That 1 plus f prime squared to the power 1/2. 1 plus f prime of x squared. I subtract those. So that makes it 4/2 minus 1/2 makes it 3/2. Which is what we were supposed to have found on the question sheet. At magnitude of f double prime 1 plus 3/2. Use the formula for k to find the curvature of that. So we have to use this formula. So 5b. Use k 1 plus f prime of x squared to the power 3/2. For this equation. Okay. Make sure my papers are together. So we have to use this formula and find the curvature of this function. So let's first find the second derivative. The derivative of ln is 1/x. Times the derivative of secant. Secant x is 1/cosine. So if we find the derivative of secant, we get 0 minus negative sine x over cosine x squared. It's the quotient. So what that means is sine over cosine times 1/cosine. So it's tangent secant x. Secants cancel. So the first derivative is negative tangent. Now we've got to find the second derivative. Sine x over cosine x. We have negative sine x, cosine x. The derivatives of those is negative cosine x, negative sine x. So it's negative cosine squared x minus negative times negative is positive. So it's negative sine squared x all over cosine squared x. Take out a negative, so we have cosine squared x plus sine squared x. That equals 1. So we have negative 1 over cosine squared x, which means it's negative secant squared x. So that's what the top equals. So y double prime is negative secant squared x. We have y prime, which is negative tangent x. We have to square it. Okay, so we can plug that in there. So f double prime is negative secant squared x. 1 plus first derivative squared is tangent squared to the power 3/2. One plus tangent is an identity. It's secant squared x. Again, that is secant squared x times the square root of secant, because x to the 3/2 is x so the secant squared x cancel. So we're left with negative 1 over secant squared x. Secant's 1 over cosine squared, so it's negative cosine squared x. And it's between pi over 2 and pi over 2, not equal to, so it's not going to be zeros. At the point of inflection, so the second derivative of the secant curve of this function, the second derivative, is negative secant squared. So x cannot equal pi over 2. That's what we know that already. So this is between pi over 2 the point of inflection is the asymptote. since negative. So but pi over 2 that's the part I have to look at real quick. Okay, so square root of secant, secant square, those cancels. So it's just cosine. All right. So now the last one was what would be show that the curvature is 0 at the point of inflection. At the point of inflection. So our K and we calculated y prime is negative tangent x, y double prime is secant squared x. What would make this equal to 0? If the top was equal to 0? Or f, well, it's just the top equals 0. Yeah, so what would make that equal to 0 would be if the top is 0, because it's a fraction. In our example here, it can't be 0 because the curvature is this is called P, the point of inflection. The only way that's possible is if the top is equal to 0. So the point is if we had that was true. And the bottom can't be 0 because it'd be undefined then. So in our example, our second derivative was negative secant squared. So where's the secant? Can't, because it's bounded by negative pi over 2 and pi over 2. Those are the asymptotes. And since this is negative, so at negative pi over 2, pi over 2, best I can conclude is it can't equal 0 because our denominator won't allow it. Yeah, it's undefined at the point of inflection. I just looked at the questions. Which one of these? The expression is an undefined, it's undefined at point of inflection. True. So it's gotta be B. Okay, the last one. So this one, told you this would be a long one because of all the steps. If you mess up any one place, then you're hosed. Number 6, the formula K equals that which just had expresses the curvature K of X with twice differential function as function X. Find the curvature function of the following curve, then graph f of X together with K of X. Okay, we know what K of X, okay. Negative 6x squared from negative 2x to 2. Okay, it's a parabola pointing down, magnitude of 6. So when x is 0, y is 0. When x is 1, y is 1, 2, 3. Negative 6. Negative 6. When y is 2, it's at negative 12. So that's f of x. And k of x of our function okay, so we have to find it with that. Okay, so we have to find the first derivative and second derivative and do all that stuff. So first derivative, negative 12x. The second derivative is negative 12. Negative 12, 1 plus negative 12x squared so it's positive 12. 1 plus 144 x squared. Okay. Well, let's reuse that. So k at 0 is 12. K at 1 equals same thing at k of negative 1, because it's the only x value in there is squared. Twelve over 145. So 1 squared is 1 times 144 plus 1. That's going to be very small. One plus 144 times 4. So the bottom is going to be here. So it starts off at 0. It starts off at 12. So it starts off and it goes down. Yeah, so our parabola is down and our curvature is up, so it's D. All right, sorry about that. I hope it didn't confuse y'all too much. Good luck, everyone. Just slow down and write things out. Use all the paper if you have to. I messed up because I rushed. Good luck.